All right, hi again everyone. Professor Sebastian back with our statistics class notes. We're moving on to section 5.2, talking about how to find theoretical probabilities. We're on page 62 of our class notes. So we talked about doing simulations to find empirical probabilities, but most of the time, if possible, we would like to know what the theoretical probabilities are. Are there rules for these things? So we want to find theoretical probabilities of what are called equally likely events. Equally likely event is an example of, if I flip a coin, the event of getting ahead is equally likely to the event of getting a tail. Okay, or I roll a die, the events of getting a 1, 2, a 3, a 4, a 5, or a 6 are all equally likely. That's what I mean by equally likely events. We would like to also find the probability of the complement of an event, and we want to use basic probability rules. So before we can get into that stuff, we need to understand probabilities and probability notation. So something happening, called an event, is usually represented by an uppercase letter, A, B, C, etc. So the probability of event A occurring is written as capital P parentheses A. So probability of event A. Probability of event A. This almost looks like function notation, but it means probability of event A occurring. So what are the properties of probabilities? Events, again, are represented with uppercase letters, A, B, C, etc. The probability of event A occurring, written P of A, probability of event A occurring. A probability is always a number between 0 and 1. Sometimes we'll say 0% and 100%, because I don't care if you put it in percentages or fractions, but it's a number between 0 and 1, including 0 and 1. So in other words, in symbols, the probability of A is between 0 and 1, or 0 is less than or equal to the probability of event A occurring, which is less than or equal to 1. So probabilities are only numbers between 0 and 1, or percentages between 0% and 100%. The sum of all possible probabilities is 1. Okay, the sum of all possible probabilities when something we're studying happening is 1. An event has a probability of 0 only if it can never happen. A 0% chance of something happening means it can never happen. A probability of 0 means it can never happen. An event has a probability of 1 or 100% only if it is certain to happen. Okay, so they can be expressed as fractions, decimals, or percents. When I'm talking about it this way, I'm talking about as numbers or fractions between 0 and 1, or decimals between 0 and 1. If I want to make it a percentage, I just multiply it by 100. So which of the following, in example 78 here, cannot be probabilities? Please explain your reasoning. So 125% chance that something happens is not possible. That can never be a probability. A probability of 5.61, that's not possible, because probabilities have to be between 0 and 1. Or negative percent, a negative 83% chance, that's not possible. Again, it has to be between 0% and 100%. So 0.74 and 0.001 are possibilities. Those could be probabilities. So the ones that I've boxed in, those are all not between 0 and 1, or 0% and 100%. So that's why they are not probabilities. All right, the complement of an event is written as A with a superscript C, so A complement. What it means is it refers to the event not occurring. So the complement of event A, again, is written as A superscript C. A complement, we say it. Example 79, let's toss a coin. If A is the event the coin lands on heads, then what is A complement? A complement is the event the coin does not land on heads. Now in this example, there's only one other thing that could possibly happen, right? Unless it really does something crazy and lands up on its, stand up on its side, but that's not going to happen. But so why do we say the event the coin does not land on heads when there's only two chances? You could say that A complement is the event the coin lands on tails, but I'd like you to get in the habit of saying it's just not what the event is. Okay, and you'll see why that makes sense, because most of the time there's not only two things that can happen. So for example 80, let's wait for a trolley outside the fort and note its arrival time. If A is the event the trolley arrives on time, then what is A complement? So the absolute best way of saying this is A complement is the event the trolley does not arrive on time. We don't want to start listing all the possible amounts of time it could be late. So we just say A complement is the event the trolley does not arrive on time. Now, the probability of an event and its complement. The way you think about this is either the event happens or it doesn't. So together, that's 100% of what could happen. Either it happens or it doesn't happen. So the probability that A does not happen, A complement, is 1 minus the probability that it does happen, or 1 minus the probability of A. Similarly, you could just say this, the probability of A is 1 minus the probability of A complement. It just means that these have to sum up to 1. So for example, let's let event A be the event a hurricane hits St. Augustine next year. And let's say that we have some information that tells us the probability of that happening, probability of event A happening, which is the event a hurricane hits St. Augustine next year, is 0.60 or 60%. So what is a complement and what is its probability? A complement would be the event a hurricane does not hit St. Augustine next year. And the probability of that happening, well, they have to sum up to 100. So since that's 60, this would be 40%. Now in formulas, we would say the probability of A complement is 1 minus the probability of A, or 1 minus 0.6, which is 0.4, or 40%.